We are going to do a problem where we are spinning an object in a circle in a vertically above our head as opposed to horizontally now. So you can imagine that we have a bucket of water. So the bucket is filled with water and it's going to be spun above our head and the water is going to remain in the bucket. We're going to find the minimum velocity needed to maintain that vertical circular motion. So if we look at the bucket at its max height, when it's at the top of its path, we'll notice that it has the force due to gravity pulling down on it, and it has tension also pulling down on it. Its centripetal force is always directed towards the center of the path, and therefore its acceleration centripetal is also directed towards the center. Its instantaneous velocity is the direction in which it's currently moving. It's always tangent to the circle. So let's say our mass is 10 grams, and let's also say that we have a 60 centimeter radius. It's not pictured. So if we start by summing up the forces in the y direction, we'll notice that we have negative tension, since tension is down, plus a negative force of gravity, also down, equals negative mass times acceleration. Since acceleration is also down, it's negative. We're looking for the minimum velocity. So in order to find velocity, we know that acceleration centripetal equation is v squared over r. So that's going to be our objective, solve for v. Well, at its minimum, the tension must be 0 because it's just making it over the circle. So the only force actually acting on the bucket is force due to gravity. So therefore, we're going to set T equal to 0 newtons in our equation. We're left with negative ma centripetal equals negative mg. Okay, go ahead and substitute our equation in for acceleration centripetal, v squared over r. We get mv squared over r equals mg. The masses will cancel since they're on both sides. Our answer is velocity equals the square root of g times radius. Gravity times radius. Let's plug them in. 9.8 meters per second squared, and at the beginning I said the radius was 60 centimeters, so 0.6 meters. We're left with a velocity of 2.42 meters per second. So the bucket's minimum velocity to make it in a complete circle is 2.42 meters per second. If it goes any slower than that, then it's not going to make it through the circle. It's going to let some water out. Okay, here's the second part. So if the velocity is actually 5.0 meters per second, what is the tension at the top and at the bottom of its circular path? Well, let's look at the top first. The forces don't change since last time. This time we actually have a tension since we're not finding the minimum. So same equation, negative T plus a negative force of gravity equals negative ma. Solve for tension this time, equals negative Fg plus ma. Substitute our acceleration centripetal equation, v squared over r, right here. Plug in our numbers. This time we're plugging in a velocity of 5 meters per second. Our mass was 10 grams, which is also equal to 0.01 kilograms. And our radius was 0.6 meters, 60 centimeters. We get a tension of 0.319 newtons. Okay, let's go on to solve for the tension at the bottom of the path. Well, let's think, is the tension going to be greater than 0.319 or less than 0.319? Make a prediction and think about why. And then solve. Okay, let's look at the bottom. So our free body diagram for the bottom changes just a little bit. We have tension up because it's the force that's pulling from the string, so it's directed towards the center of the circle, and acceleration centripetal still directed towards the center of the circle. This time force of gravity is directed down. It was directed down earlier, but it's opposite of tension this time. Well, when we go ahead and plug them into our equation, we get our sum of our forces. Our tension is positive this time because it's up. Force of gravity is still negative because it's down. And ma is positive because acceleration centripetal is up. So we're still using our up equals positive, down equals negative convention that we've used from the beginning of our forces unit. Let's solve for tension. We get mac plus fg. Well, this is different from last time. Last time we had tension equals mac minus fg, so we should be able to predict right now that our tension is going to be greater. Go ahead and substitute AC equals v squared over r. You get mv squared over r plus mg. Plug in our values. So 0.01 kilograms times 5 meters per second squared divided by 0.6 meters. Okay. When we solve, we get 0.515 newtons.